value on there. All right. What?
You're not following it.
I just deleted something. Okay, all right, here we go. So, guys, today we're talking about multiplying rational expressions and dividing rational expressions. It's going to be a lot like what we did yesterday. We just got a few more steps, a little more to do that. So, first, before I even do that though, how do you multiply fractions? Across, right? I multiply tops. 2 times 4 is 8. Over 3 times 5 is 15. Right? You multiply the top pieces, multiply the bottom pieces. What about like 3 over 4 times 10 over 6? Same thing, you multiply across. 3 times 10 is 30. 4 times 6 is 24. And that would reduce to, 5 over 4, right? Now, is there a different way you could have done that? You could simplify them first. Now, when we are multiplying rational expressions today, that's what we're going to do. We're going to simplify them first before we multiply. It's going to make things way easier with rational expressions. With a fraction like this, it probably doesn't matter to you guys, right? It doesn't matter if I take a 3 out of here and 6, and a 2 out of 4 and 10. 1 times 5 is 5, 2 times 2 is 4. I get the same answer. With a normal fraction, that probably doesn't mean anything to you. It doesn't matter, right? You know how to do 3 times 10 and 4 times 6 and reduce them. You know how to do that. With the rational expressions, do you want to be multiplying x squared plus 5x minus 2 times x squared minus 7x plus 3? No, you probably don't want to do that. So we're going to simplify first and then multiply. Okay, so that's why we brought that up with the fractions. Is that what it says right here probably? You should always try to simplify first, right? Look if there's common factors. Yes, you might have to factor. There's like a 95% chance you will factor every problem before you simplify. Just, it's how it is, right? That's what we did yesterday. It's pretty simple. Okay, so let's try some. 7 over 8 times 2x plus 4. Simplify, excuse me, not simplify, factor first, right? I can't factor 7 over 8. That just stays the same. But the second fraction, I can take a GCF out of 2x plus 4. I get 2 times x plus 2 over 21. All right. Now, when I am simplifying, anything in the numerator can cancel with anything in the denominator. It doesn't matter if it's in the same fraction or not. All right? So if I want to take, let's say, I have a 2 in my numerator and I have an 8 in my denominator. Okay, what can I take out of both of those? 2. I'm going to do that. I'm left with 1 and I'm left with 4. It doesn't matter that they're in different fractions. All right, I can still simplify that because if I multiplied it, they'd all be in one fraction anyway. Is there anything else I can simplify here before I multiply?
21.
The 21 and the 7. Good, I can take a 7 out of both of those. Okay, so 1 times x plus 2 is just x plus 2 on top. 4 times 3 is 12. Is there anything else I can simplify there? I can't simplify the 2 and the 12? Why not? Because it's not multiplication, right? This is one whole term. X plus 2 is one whole term, so I can't simplify those. That's my final answer. And notice, it didn't ask me for restrictions. Guys, I'm pretty sure 99.99% of the time, if we're doing multiplication and division of rational expressions, we're not going to ask you for the restrictions. All right? If we're just asking you to simplify one, then we might, but not with multiplication and division. All right, our second one here. 12x squared y over 5y squared times 2xy over 3x squared. Can I factor anything? No. But then I can start simplifying right away. Right? What can I simplify here? Top and bottom. 12 and 3. I can take a 3 out of both. I'm left with 4. I'm left with 1. Okay, is there anything else that I have both top and bottom? Any factors they share? Y. So if I look, I have one y here, which means I can take a y right there. I'm left with just y. Okay? Is there anything else?
X squared.
What?
X squared.
X squared, so I have an x squared on top and on bottom. Technically I'm left with 1 for each of those, but you don't have to put it. Right? Anything times 1 is itself. Anything else? What, Aubin?
Y again.
Y again, right? I have a y over here and a y in my denominator, so I can cancel those out. Alright, when you are going through this, be very careful you don't lose anything. Right? I have 4 times 2x, which gives me 8x in my numerator. 5 times, and this is just 1 over here now, right? I canceled all that. So 8x over 5. If you need to, guys, do one term at a time and then rewrite your fraction right away. Right? If you can't handle doing it all at once and then piecing it together, do one at a time, rewrite your fraction. Do another one, rewrite your fraction. It might take you longer, but it'll be way more organized. Okay? Any questions so far? Those were kind of the easy ones. Another one on here. Oh, there are. Perfect. 7y over y plus 2 times 2y plus 4 over 21. Can I factor any of those? Yeah, which one? 2y plus 4. I can take a greatest common factor out of there. So 7y over y plus 2 times, I can take a 2 out of both those pieces. 2 times y plus 2 over 21. Alright. I factored everything that I could. Now I can start simplifying. What common things do I have in the numerator and denominator? What was that, Sid? Y plus 2. I have that whole term in both numerator and denominator, so they can cancel out or they can simplify. Do I have anything else? 7 and 21. I can take a 7 out of both those. It becomes 1, becomes 3. Like I said, it becomes 1, but do you have to put that there?
No.
No, 1 times anything is itself. Anything else you can see right now? Okay, then let's do our multiplication. If I multiply the top, Conan, what do I get? Thank you, Natalie. Asking Conan. 2y, right? I'm left with y times 2, which is 2y. Kylie, what am I left with in my denominator?
3.
3, right? I'm just left with the 3. It's technically 1 times 3, which is just 3. And that's as far as I can simplify. Alright, very good. Good so far?
Yeah.
Okay. Let's keep cruising, because we don't have a ton more to do. Our next one, 15 times 4x plus 5 over 6. Hey, can I factor anything there? No. But everything we've done so far has been fraction times another fraction. Over 1. Put it over 1, right? Put it over 1. Now it looks like a fraction times a fraction. That makes it way easier, right? Hey, Faith, do I have anything in the numerator and denominator that have a common factor? We have a common factor of 3, right? And our 15 and our 6. So I'm going to take a 3 out of here, I'm left with 5. Take a 3 out of 6, I'm left with 2. Okay? Does that make sense so far?
Yes.
Do we have questions?
No.
So on top, I'm left with 5 times 4x plus 5 over 1 times 2, which is 2. Does everyone see where those pieces come from?
No.
No. Alright. So we take a 3 out of here, right? And a 3 out of here.
Oh.
I was left with 5, and I was left with 2.
Yep.
Does that make sense?
Yeah, that was it.
Okay, good. Now, can we do anything else to that? No? Like I said it yesterday, I think I said this yesterday, I would distribute that 5 throughout it, makes it look cleaner for an answer. 5 times 4x is 20x. 5 times 5 is 25 over 2. Okay? Yes, Sid?
Just to be clear, we don't have to simplify it, though, right?
You distribute?
Yeah, that.
I would say no. I don't think that matters too much. If you put this on the test, I won't mark it wrong. I'm not sure what Miss Furman and Miss Jex are doing, but I think that's fine. I don't need you to distribute, but I do just because I think it looks cleaner. Okay? Does that answer your question? Okay. All right. So we've gotten through 4 so far. Do we have any questions?
No.
The next 2 are going to be more difficult. Jonathan.
I lost my packet. Can I get another one?
Yeah, if you look in the Monday on the left-hand side of that big tall slot, there's extra packets in there.
Thank you.
Yep. All right. So we keep going down. E, x squared minus x minus 2 over 3 times 21 over x squared minus 4. First things first, I should try to do what? Factor. So can I factor any of these pieces?
Yes.
Which ones, Ange?
21.
Ooh, that's simplifying. I don't want to simplify it. I want to factor first. Both of them?
The numerator of the first one, the denominator of the last.
The numerator of the first one, the denominator of the second one. Good. The numerator of the first one, I can factor to x minus 2, x plus 1 over 3, right? Use either your box method or your guess and check or your grouping, whatever you do to factor it. Times 21 over, hey, that denominator, what do we call that?
Perfect squares.
Difference of perfect squares. Very good. I get x plus 2, x minus 2. All right. Now that I have it factored, and what do you got for me?
You get rid of the x minus 2 on one.
X minus 2 in my numerator and denominator. I can get rid of that whole piece, that whole term. Okay? What else? Someone besides Ange. Renee.
3 and 21.
3 and 21, I can take a 3 out of both. I'm left with 1, and I'm left with 7. Good. Is there anything else we can simplify there? No, so we're going to start a multiplication here then. X plus 1 times 7, I'm just going to write that as 7 times x plus 1 over 1 times x plus 2. Alright, and?
Could you just make it 7x plus 7?
You could. Well, can't I just cancel these x's out?
No.
Why not?
Because it's a factor. Because it's addition.
It's addition, right? It's a whole term here. X plus 1 is the whole term. X plus 2 is the whole term. You can't do that. So then yes, if you would like to, which I would like to, you can distribute your 7. 7x plus 7 over
Can I answer it?
x plus 2. No.
Phone.
Thank you.
Right there.
Zelda. You're calling the wrong room. You're good. Bye. Alright. False alarm. Okay. Next one, F. X squared minus x minus 6 over 3x minus 9 times x squared minus 9 over x squared plus 6x plus 9. Whew. We got a lot of things we can factor here, right? Alright, so let's get at it then. First thing we can factor, our numerator up here. What is that going to factor to? What multiplies to negative 6, adds to negative 1? Negative 3 and plus 2. So x plus 2 and x minus 3 over my denominator. What do I do to that? Take out a greatest common factor, right? Take a 3 out of both. 3 times x minus 3 times. My numerator over here is what we call a what? Difference of perfect squares, or difference of squares. I get x plus 3, x minus 3. Alright, and then lastly, my denominator over here, I factor to x plus 3, x plus 3. What multiplies to 9, adds to 6. Right? Okay. Well, now that we've done that.
Can I answer it this time?
No. Who's popular today? Not a big deal. It's the same number.
Probably not.
Is it all, George? Hey. 252. Yep. Fine. I think we should be good now. Alright. What terms do I have on top and bottom that I can simplify? What do you got? What's the first one? X. Does it matter which x minus 3 I use? No. But guys, I can only simplify one of these. Right? I can't take both of these away to 1 on the denominator. Right? 1 per numerator, 1 per denominator. They have to match up. Alright? Yes, Ange.
So then could you technically just, for the numerator, the last numerator, could you cancel out the x plus 3 for the numerator and denominator, and then cancel out the x minus 3 from that numerator and the other up denominator to make that top numerator 1?
So you're saying cancel this x minus 3 instead of this one?
Yeah. And then
You could have, yeah. I mean, you don't have to. You can do the first one or the second one. It doesn't matter which x minus 3 you use. But because you only have 1 in the denominator, you can only cancel 1 in your numerator. Cool? Okay. Alright, so we also canceled an x plus 3 on top and bottom. Is there any other things we can simplify right now? No. So I'm going to do x plus 2 times x minus 3 over 3 times x plus 3. Alright. Should I leave that as my answer?
No.
No, that one's not okay, right? We need a FOIL. Like I said, if you have just the distribution part left, that's fine. But the FOIL you need to do. Alright? We get x squared minus 3x plus 2x minus 6 over, and I'm going to distribute down here. 3x plus 9. Last thing you got to do then is add my like terms. X squared minus x minus 6 over 3x plus 9.
Okay, give me the x's already.
And that's my answer. We're not done yet. We have 2 more. Alright. Hey guys, I know I sprinted through the end of that one. Are there any questions that we have? On a scale of good, so-so, or how's it been so far?
In the middle of good and so.
In the middle of good and so-so? Okay. Alright. Then, that was multiplying things. Shh. What about when I divide fractions? How do I divide a fraction? Renee?
Don't you change the reciprocal for one of them?
Yeah. So, we multiply by the reciprocal. Perfect. We do what, I don't know if you guys have heard it before, but you keep, change, flip. You heard that before?
Yes.
Where you keep your first fraction, you change the division to multiplication, and you flip your second fraction, 21 over 10.
Oh, yeah.
It's the same thing as multiplying by the reciprocal. Some people prefer to say multiplying by the reciprocal. Some people prefer to say keep, change, flips. It helps them remember it better. Either one you use is fine. I don't care what you call it. But we're multiplying by the reciprocal, and then same thing. Factor and simplify first, and then write your answer. Now, if you're doing the fractions like that, you probably don't need to do it. But the big thing here is, how do you divide 2 fractions? You multiply by the reciprocal. We're going to do the same thing with rational expressions. Instead of doing x squared plus 6x minus 7 over 3x squared, divided by x plus 7 over 6, I'm going to do x squared plus 6x minus 7 over 3x squared times 6x over x plus 7. Right? Keep, change, flip. Multiply by the reciprocal. Now guys, when you get really good at this, you're going to be able to do that step and factor at the same time. Now do you have to do that? No. You can write them all out. But once you get better at it, you'll be able to do it all in one step. So first things first. Now it's just like the problems we did before. We were just doing. Factor everything first. My numerator over here can factor to x plus 7, x minus 1 over 3x squared times 6x over x plus 7. Well, do I have any terms that are alike in my numerator and denominator?
X plus 7
X plus 7. Did you have a question?
Yeah.
Okay, what's your question before I move any farther?
Do that and then I'll have to.
Okay, so we have X plus 7, X plus 7. Those cancel out. Okay, question.
For 3x squared and 6x, couldn't you take out a 3x out of 3x squared and then make that 2?
Yes, so we'll do that in a second.
Oh.
Okay? You're just getting ahead of the game, but yes, you can. Alright, then we have 6x and 3x squared. Now I like to do it in pieces. Like I like to do the 3 and the 6, and then the x squared and the x, just because it helps my brain. But if you want to do it all at once, you can. So I can take a 3 out of both the 3 and the 6. I'm left with 1 and 2. I can take an x out of both x squared and x. My x on top just cancels out. Is there any other terms that I can simplify? No. So I'm just going to do my multiplication. 2 times x minus 1 over, I'm left with just x in this denominator. Now, like I said before to Sid, if you want to leave it like this, you're more than welcome to. I like the cleaner look. I like to distribute 2 throughout it. 2x minus 2 over x. Alright? How do we feel? Do you feel comfortable or you want to try the next one on your own?
Yeah.
Okay, do the next one on your own. How about this? You do it on your paper, and I'll do it on my paper, and we'll compare answers. Cool?
Can this be our other slip?
No. Sorry.
I was gonna say.
See, I make mistakes sometimes too. It's fine. Don't do that. You knocked the window out of my way. Thought it was funny. Oh, what time are we out of here?
25.
Are we seriously?
Yeah.
What?
Yeah.
We had so much fun. Oh, I guess we can't do anything this way.
Yeah.
Alright, hey guys, please check your answer with mine. How did we do?
Great. Fantastic.
Okay. I'm sorry we did not get any work time today. That was not my intention, I swear. I apologize. Hey, did I tell you guys about next Tuesday already?
Yeah.
Okay.